All right, so we're going to work through this practice test. Going to go kind of quickly through this, but you can use this to check your answers and maybe get a few tips along the way. So we got 1/3 x to the third, we are 3 to the x. We've got to graph this guy. So we've got to find some points here. We know that 3 to the x normally goes through 0, 1. However, this 1/3 is going to make it go 1/3 of that. All right, that's not going to work so well. Okay, so it's going to be 1/3. That's huge. Well, let's try this again. Darn thing. Well, it's going to go through 1/3 there. And then 3 to the first is usually 3, but we're going to drop that down 1/3. 3 to the second is usually 9, but 1/3 of 9 is 3. Okay, and then we have a third, a third, a third. It's going to look like this. We're going to have an asymptote of the 0 axis. And that is the x-axis. All right, so here we've got 3x plus 2. This is going to raise our asymptote up 2 there. So that's 2. And then our 3 to the x is going to go through 0, 1, 1, 3, and then 2, 9, somewhere up here and off to the left. Make sure you draw that asymptote in there. Something like that. Okay? All right, number 2 actually. Okay, so we're going to shift this here. We're going to shift it left 3. So we've got g of x, we'll give it a different name, equals, left is going to be inside the exponent here. So that's going to be x plus 3, because it's opposite from what we'd expect. It's going to go down 4, so that's going to be minus 4 out front. And it's going to reflect across the x-axis, so that's a vertical flip, so that's negative out here. For this guy, we're going to make the shift, and it's going to go right. So we've got our 3. It's going to go right, so it's going to be x minus 3. It's going to go 3 units up, so we're going to add 3 out here and reflect across the x-axis. By the way, if we reflect across the y-axis, we'd want to put a negative up here in front of that x there. Okay? Here, which one of these guys has the smallest a value? So this is just a general exponential function. So remember, the a is the initial value, and the b is the growth rate, okay, or decay rate. So if we have the smallest a value, well, a value once again is the initial value, so that would be this b, okay? So b, and it has the lowest y-intercept, okay? Which value has the largest a value? Well, that's looking for the largest intercept, and that's up here. That's going to be c. And so this is the largest y-intercept, okay? Which graph has the smallest b value? Well, small, we're talking a fraction. Fraction means exponential decay. There's only one here that has exponential decay. This is exponential growth. This is really exponential growth, but it's flipped upside down. So this is like a negative, I don't know, negative what, 2 to the x or something like that, all right? Actually, this is negative 2 to the x. This might be negative 4 to the x. All right. So anyways, so this is exponential decay. Our b value is a fraction here, so that is graph A, and because our b there would be less than 1 and greater than 0. Okay, the largest b value, well, that'd be the steepest one here. These have negative a values here. That's why they're going upside down, all right? But what we've got to do is we've got to check how quickly it's going up. Okay, this here has an a value of 3, and so the b value is a little tough to see here. This here has an a value of 4, but if we just look at the steepness, and it'd be nice if we could see another point up here, but we can't. So that one is steeper than this one, and so we're going to call that C because it's the steepest graph. Okay? Let's go on to the next page here. Section 4b, we're graphing logarithmic functions here, and so we got some transformations again. Okay, this minus 4, like usual, is going to go right 4. Inside is left or right, and this plus 7 is going to go up 7. Okay, the transformations here, we're going to go left 2, and we're going to go down 3 because of our negative 3 there. This is a vertical change. Outside is a vertical change, and so we got a vertical reflection and vertical stretch of 2. Okay. The domain of a logarithm is when 3x plus 1 has to be greater than 0. So we subtract 1 from both sides. 3x is greater than negative 1. Divide by 3. Divide by 3. X is greater than negative 1/3. Okay, so the asymptote is at x equals negative 1/3, and the domain here would be from negative 1/3 to infinity because it's greater than. Remember to watch out, and for some cases when you divide by a negative number here, you'll have to flip that inequality there. So, all right, describe the transformations for log base 2. Okay, so we're going to describe and graph. So we got a minus 2 here. Minus 1 is going to go right 1 and up 2. So normally a logarithm curve, our plane old logarithm curve, has an asymptote of the y-axis, but this right 1 is going to give us an asymptote of 1. Okay, let's get a scale here. That's 1, that's 1 there. Okay, don't forget to label your axes somehow. That's an ugly 1. 1, 2, 3, 4, 5. How about this? Okay, so we got that. Now we're going to go up 2. So what we've got to do is this. If we go up 2, I'm going to locate this point, and I'm going to make a little mental note. I'm going to actually put a physical point there. That's like my new origin. The origin has gone right 2 and up, right 1 and up 2. Okay. If you want, you can even draw in a little dotted line now. Treat this like your asymptote. Like your x-axis. Okay, it's not an asymptote, it's an x-axis. The vertical line there, the vertical dashed line, is the asymptote. So from this point, now let's think about how we graph y equals log base 2 of x, all starting from this point right here. So we know that it goes through 1, 0 normally. Well, from this new origin, we go right 1, and there's our point at 1, 0. Normally, this logarithm curve goes right 2 and up 1, because the log base 2 of 1, log base 2 of 2 is 1. Okay, so we're going to go 2, 1. Again, I'm counting from the new origin. Then I'm going to go over 4 and up 2, because 2 is the exponent we put on 2 to get 4. Anyways, there's the graph there. That's the idea. Find your translated origin and graph from there. Okay, here we're going to go just down 3. Okay, so we have the same asymptote. Our asymptote is the y-axis here. 1, 2, 3, 4, 5. 2, 3, 4, 5. Label it up. Okay, but it's going to go down 3. So 1, 2, 3. Again, if you want, you can go ahead and put a little dotted line here. It's not part of the graph, but it's just kind of a helper line. That's like our new axis. This is like our new origin. So treat this as the origin, and let's graph y equals log base 3 of x. Okay, so that goes through 0, 1, 1, 0 actually, 3, 1, 9, 2, and then it's going to go down, down, down. Okay, so find that translated origin and draw your graph in. Let's move on to 4C. Okay, 4C here, we want to solve some problems with exponential functions. Okay, so given this function here, we want to determine if it's exponential growth or decay. That all is determined by the b value. So this is going to be exponential decay. And the reason is because 0.5 is less than 1. Okay, the b value is less than 1. This guy right here, looking at the b value, okay, this is going to be exponential growth. Now, even though it's in the negative direction there, we're still going to call this exponential growth. Okay, because 1.2, the b value, is greater than 1. Now we want an exponential function that goes through these 2 points here. Well, we want it just a simple y equals a times b to the x. So substitute 0 for x and 5 for y, and we get this, 0. And b to the 0 is just 1, so a is 5. Now we've got that a is 5, so we can find our b value. So we got y equals 5 b to the x, and let's substitute this 405, so let's put 4 in for x and 405 for y. So 5b to the 4th. Let's divide everything by 5, and we've got 81 equals b to the 4th. Take the 4th root there, and we have that b is 3. The 4th root of 81 is 3. So now we can write our function y equals 5 times b to the x. Nope, b in that case, we just found out what b is. B is 3. Okay? Don't forget to rewrite your function. Okay? One more, same idea. Plug in 2, 2, and 4, 8. Well, if we plug in 2, 2, we get y equals a b to the x. So we have 2 equals a b to the 2. All right, we could solve this for a, and that gives us a is 2 over b squared. Then we can plug in this other point here, and we know that y is 8 when x is 4. If we plug this guy into here, we get 8 equals 2 over b squared times b to the 4th. So 8 equals 2b to the 4th all over b squared. Well, these are going to cancel there, leaving us with, let's see, 8 equals 2b squared. So divide by 2, and b square root, b is 2. Okay? It could be 2 or negative 2, actually, but b cannot be a negative number. So if b is 2, we can come all the way back over here, plug that in, and we see that a is 2 over 2 squared, which is 2 over 4, which is 1/2. And so our function y equals 1/2 times 2 to the x. Okay? All right. Solving exponential equations, we want to we want to take the logarithm basically, unless we can find a common common base. Now, 216 is really 6 to the 3rd. So we have 6 to the 3rd to the x minus 5. And let's rewrite 36. Well, that's 6 squared to the x plus 2. You want to be familiar that 216 is 6 to the 3rd power. Now we're going to multiply these. This is 6 to the 3 times x minus 5. Power to power, we multiply. This is 6 squared to the x plus 2. And since we have a common base here, we can say that these guys here, these exponents are the same. So 3 times x minus 5 equals 2 times x plus 2. Okay, and so that's 3x minus 15 equals 2x plus 4. Solve that up, subtract 3x, add 15, we get x is 19. Okay? Over here, you want to subtract 8 from both sides first. We get 3 to the 2x plus 1 equals 27. We can rewrite this 27 as 3 to the 3rd power. And so now we know that 2x plus 1 equals 3. Subtract 1, divide by 2, we see that x equals 1. Okay? Another way you can do this is you could take the log of both sides. We could come back here, we could say take the log of this and the log of this. We can take that exponent down there. Okay, this is going to get a little uglier, but it works. Log 3 equals log 27. And if you divide both sides by log 3 here, squeeze in there, okay? If you divide both sides by log 3 and you go to your calculator and figure out what this is actually going to give you 3. Log of 27 divided by log of 3 is 3. And that'll put you right to here, which gives you the same answer, okay? Here, 5 to the x, well, this 625 is 5 to the 4th. And so that is, another way to write that is 5 to the x equals 5 to the negative 4. And so x is negative 4. Okay. Last but not least, could this be an exponential function? Well, we got to check the factors here, the difference, the quotients. 2 divided by 1 is 2. 4 divided by 2 is 2. 8 divided by 2, or 8 divided by 4 is 2. We have a constant multiple there. We're multiplying by 2 times 2 times 2. So yes, okay, we have a constant multiple of 2. Or actually, yeah, that's fine. Constant multiple of 2. Okay? All right. What's a better way? I just don't like that multiple here. Probably a better way to say that would be it's not a constant multiple, it's a constant ratio is what it is. That's a better way to say it. Okay. Next, we're going to go on to logarithmic equations. So let's look at 4D, some logarithmic equations. So if it's a logarithm, we want to change it to an exponential. Swing this base around. We're going to raise both sides to 3 power, or you can think of using the definition there. We've got the square root of x minus 2 equals 3 squared. And so that's just 9. And the opposite of squaring is, or opposite of square root, that is squaring. So x minus 2 equals 81. And add 2, and we're done. Okay, and if you plug in 83, you'll see that it does work. Over here, we've got a natural log. So let's subtract 5. And we've got natural log of 0.02 x equals negative 10. Remember, this is base e. So we're going to raise both sides to e, or you can think of it as using the definition of a logarithm. And we got 0.02x equals e to the negative 10 divide by 0.02. I like to put that 0 in front. X equals, now this negative 10 here, we'll drop it downstairs. It's negative on top. It's going to be positive on bottom. So we got e to the 10th times 0.02. Got to leave something on top here. If you want to clean up a little bit more, we could multiply top and bottom by 100. That'll move the decimal over there, and we got 100 over 2e to the 10th. And that can be written as 50 over e to the 10th. There's our exact answer, and that's fine. We weren't necessarily asked to write a decimal, but you can get your decimal approximation if you want. All right, 23. Write in exponential form. 6 to the negative 4 equals x. And so this is x equals 1 over 6 to the 4th. And that is 1 over 1296. Exactly. Number 24. Let's divide by 3. We get a beautiful 50/3. And now let's write in a logarithmic form. X equals log base. Actually, let's think of this a different way. Let's go and take the log of both sides. You can do this a couple ways. But let's take the log of both sides. Log of 8 to the x equals log of 50/3. Bring the x down, and x times the log of 8 equals the log of 50/3. Divide by log of 8. If you went the other way that we were starting out there, you just have to use the change of base, which would end up with the same thing, log of 50/3 divided by log of 8. And you can use your calculator for that. Watch out with your parentheses there. And we end up with 1.35 approximately. All right, over here on 25, we're going to use the change of base formula. Log base b of x is log of x divided by log of b, so we're going to have log of 12 divided by log of 4. Use your calculator. Don't forget to close your parentheses. Log of 12, close the parentheses, divided by log of 4. Gives us about 1.79. Okay, make sure you know that formula for the test there. Same thing here, even though we got a fraction, we're going to have log of 26 over log of 1/3. And using our calculator, we get about negative 2.97. Okay. And now we're going to write these as a single expression, a single log. First thing we got to do is we got to put these powers up. And so we have log base 3 of x squared plus log base 3 of y to the 4th minus log base 3 of z to the 3rd. They're all base 3, so we can combine these things using our product rule. We have x squared times y to the 4th, adding logarithms, the same as multiplying. And now subtracting logarithms means division. We can change that into division inside the logarithm. X squared y to the 4th all over z cubed. Okay. B here, let's put these exponents up. And when we put the exponents up, we get log base x of w to the 4th plus log base x of y to the 6th. We're adding, so that's going to be put together as multiplication, w to the 4th times y to the 6th. And there you have it. Now we want to break these apart. So we're going to do the exact opposite of what we just did. So let's break up the division first. Log base 2 of x squared minus log base 2 of a squared b cubed. Now break up that multiplication, log base 2 of x squared. Watch out here though, you got to put that in parentheses because that minus is going to affect both of these. Let's see here. Oh, I can't change that now. I got to squeeze this in there. Log base 2 of b cubed. Sorry about that. And then that negative gets distributed, so we have log base 2 of x squared minus log base 2 of a squared, and minus, this is a minus log, not hog. It looks like hog. Got to work on writing better here. So that's minus log base 2 of b to the 3rd. Bring the exponents down, and we are done. Log base 2 of x minus, bring the exponent down here, to log base 2 of a, exponent down, minus 3 log base 2 of b. And there's our answer, expanded. And last but not least, we got our interest problem here. We've got our formula, A equals P times E to the RT. Now we want to calculate the number of years to make $250 become $750. So we have A is the final amount we want. Okay, the final amount we want is $750. P is the starting amount, so that's $250. E is the natural number E. Don't try to substitute for E. interest rate is 4.3. We've got to do that as a decimal. And then t is the time in years. Okay? So let's solve it. It's an exponential equation, so we got to get the exponential all by itself. Let's divide it by 250. 3 equals e to the 0.043t. Take the natural log of both sides, or just change it into logarithmic form. The natural log of 3 is 0.043t. Swinging the exponent around here, or the base, I should say. And let's divide by 0.043. Divide by 0.043. So t is natural log of 3 divided by 0.043. And that is natural log of 3 divided by 0.043. That is 25.5 years. Okay? And there you have it. All right? Good luck, study hard, and you're going to do great. Keep it up.